Okay, so today I think we stopped here last week. Product development continuum. So all products will have this life cycle. When the product life cycles are shorter, especially today, life cycle of product is shorter because of the rate of technology change. So fast, technological change, for the past probably 40 years, 30 years. Okay, so you need to develop a so-called product development continuum. Okay, so you can develop product faster and will result into competitive advantage. Because we are in a time-based competition, time is of crucial factor in any new product or new technology. For example, the vaccine. Those who can produce fast vaccine can, sell it to the market. This COVID-19 case. Okay, so probably they already have their own set of previous technology. Okay, only thing, for example, today the latest technology is the mRNA. That is the not using the traditional method of developing vaccine. Anyway, there is the so-called product development continuum, meaning how do you manage to actually develop new products? If you are very new, you cannot develop new product as fast as those companies who are already advanced. Or if you want to be advanced, how should you do it? Okay, so you can have you have this internal as well external. Okay, internally, for example, you migrate existing product. Migrate means you just improve and you come up with new cosmetic changes, especially like cars. Okay, they migrate, or you enhance existing products, or even you can use a new internally developed product. You develop new technologies. Okay, but it is done internally. New technologies, new product internally. Okay, that's internal development strategies. You can also think about how you can have alliances. Alliances mean you have a network of design, centers across the world to actually become your alliances to develop your new product. Or if you don't have that alliances, for example, Mazda and Ford alliance, okay, or even Renault and Nissan alliance, okay. So car companies also do that, or even service companies, airlines, they have alliances, okay. Or you do JVs, joint venture, because you don't have the technology. For example, you do not have the technology to build this kind of new battery. So you have JVs, joint venture, between one company and another company. Or you can buy technology. Of course, it's going to be expensive in the early stage. So you can purchase technology, or you acquire the developer. That is the reason why companies, they buy companies. Geely, for example, they buy Volvo because they want the technology to make very advanced, safe vehicles, safe cars. Okay, and of course, they can exploit that technology. Exploit means you utilize. Okay, you further advance. Okay, so the three things that has to be looked is, when you have the cost of product development. Okay, either if you have external, then you have shared costs. But of course, if it is internal, it's internally you have to bear the cost by yourself. Okay, so looking at in terms of cost of product development. So if you're external, you can share the cost. Internal, totally internal, resources needed. In terms of speed of development, how fast you can develop. Obviously, if you have external, rapid and very fast, you can just take the technology and use it. You don't have to develop internally or locally. Okay, so for internal, it's going to be very long time. The risk, of course, high internally if you don't have the technology. But if you share, if you go external, you can share the risk. Understand? So these are the things that, not only these three things, there are many other things that will probably impact on your product development speed, product development cost, product development risk. Okay, so this is and companies must decide. So companies must decide. This is their strategies. How to move fast in business. And it's explained further here. Okay, it's explained further. Purchasing technology by acquiring a firm will speed up development. Will of course, when you buy the technology, then you need to fit between the company's system and your own system. So there can be some mismatch. So you need to try to fit the different technology. Very simple example. The other company that you buy, may be using a different dimension system. For example, they use inch, feet, imperial. But your company is using metric system, for example. So how to match that? So you need to convert their drawings, the system into common, that fit both the acquired company and the your own existing company. Joint venture is very good because both organizations will learn and the risks are shared. Okay, there's a lot of things which are joint venture, especially like construction, construction projects, or even new highway, high-speed rail. The world's top two is probably China and Japan. So China and Japan is competing to sell their high-speed rail to Malaysia, to Indonesia. Recently, Indonesia, they use China-based, what you call, it's a joint venture, okay, to develop the high-speed rail in Jakarta, the Java island. Okay, you can read about that actually. And through alliances, cooperative agreements between independent organizations. This is actually useful when you're developing technologies. Okay, developing technologies like there's a lot of alliances in the COVID-19 vaccine development. Okay, Pfizer, BioNTech alliance. Of course, it reduces risk. Right, so that is the product continuum that needs to be considered when you are involved in product design and development. Okay, now, so we move on to defining a product. How do we actually define a product? So when you develop a product, we need to have some kind of system in order to be systematic in recording and also in making sure that we can actually manufacture the products. All things that we produce must have some kind of drawings. Nothing in this world that does not have drawings. Okay, being an engineer, we have seen a lot of drawing. Probably some of you may not have yet seen a drawing, or maybe it's just a picture. Okay, I will show. There are some examples given after this. Right. The first definition of a product is in terms of its functions. That's the most important thing. Product you must define what it can do, what it cannot do. Okay. And specifications are developed during the design phase. For example, we design a material. Use this material. Use steel. So we want to know how strong the steel should be. So in engineering, we have the tensile strength, we have probably the, the stress strain and so on. So you don't have to worry about that. Let the engineers worry about that. But at least there are specification, there are rubber specification, there are specification for lighting, everything. And manufactured products will have an engineering drawing. As well as, this is one thing, engineering drawing. There's also bill of material. So bill of material lists the component of a product. To make, for example, this pen. Okay, so what do you need? You need the string, you need this. So there are bill of material. Basically simple list of materials. For example, you want to make a cake or, tempura. So you must have bill of material, bill of raw material, list of material. Okay, same like making car, making telephone, make anything. Okay, so technically it is called bill of material. Will list the components of a product. Okay. This is just an example of specification of a food. Okay, so this is US regulations. Even cheese, they have characteristics and specifications. So this is grade AA. This is the product name. Product name is Monterey cheese, and it says shall conform to the following requirements. What does it mean? It means that in order to have grade 8A, first, flavor. So this is the description. Body and texture. This is the description. Small mechanical opening, even in the process, you shall not possess sweet holes. So the people who are in the cheese industry will understand these requirements. Okay, color, finish and appearance. Okay, so all products. See this example of the product specifications. Let me just specifications. So it's actually in the book. It says specification for US grades of Monterey cheese. Okay. Right. Anyway, for this is a simple product. You can go for engineering products, because engineering products is much more complex. You look at aeroplanes, then you can see the drawings that is required for making the aeroplanes. Okay, so there will be engineering drawing. They will show the dimension, the tolerances, the material to be used, and will show coding for group technology purposes. Basically, just trying to group the parts. Okay, because some of them are different sizes. And again, bill of material, which is the list, which is listing the components to the extent of quantities and where it is used in the product. Okay, and it will also show the product structure. Basically, it will show in terms of final product and how it actually join up, where it will join up, and how it's going to be completed at the end of the day. So a typical example of engineering drawing. Okay, this is an engineering drawing, 3D view, top view, side view, okay, auxiliary view. So it says, if you look here, the material, the heat treatment, the finish, so these are all engineering requirements. So this is an engineering drawing. Okay, you can Google the internet and type engineering drawing and put the engineering drawing automobile. Like you can see, what kind of drawings available for a car. And this is bill of material, which is actually a description of all the components needed to make that parts. So imagine small parts, sub-assembly, bigger assembly, and so on. Okay, and the quantity required. For systems purpose, you need to number them. Why? If you want to order, if you don't have a number, then you're going to mix up with, for example, other types of parts. Okay, so you need numbers, as well as In the process, you need also the numbers. If you don't have the numbers, you will mix up. Okay, so this is for making it very systematic. Okay, so bill of material must have part number to make it complete. Actually, it's actually part number, part number, part number, part name. Okay, this is part name or the description. And how many do you need to make it the final product? To complete the final product, you know, you need one roller, one pin, one lock nut. Okay, so that is bill of material. Same like bill of material for cheeseburger. So you can just imagine, in order to make one cheeseburger, so you need all this material. Then it will be assembled. Simple. Okay. So all products. You know hamburger, burger wakarimas. So he says here, burger set lettuce, tomato, red onion, pickle. So maybe I can ask you to do, bill of material for example, tempura. Okay, so I want a bill of material for set of meal. Okay, related to that is actually group technology. You don't have to worry about this. It's actually grouping. Parts are grouped into families with similar characteristics, and because of systematic way of trying to coding, you need to have this coding system, especially when going to help you in the manufacturing process. Right, so the coding system will describe the processing and the physical characteristics of the grouping. So it's like this, basically. So this is ungroup. Ungroup means, these are all the parts that you need. But if you group them, okay, so this is grouped. 1, 2, 3, 4, 5, 6. This fall under the grouped. This is slotted. Why it is called slotted? Because the parts has slots. The slots, okay. Threaded because they have thread. Drill because they are drilled. So when you go for the drilling process, of course the sizes are different. So that's why it's grouped together. This is a machine. Machine means you do some smoothing and some cutting. Okay. So this is group technology scheme, which is actually very helpful when we are trying to design new products. You're going to use the same material, same parts, so it's going to be helpful, especially in manufacturing as well as designing new products. Okay, so this is called group technology. Okay, coding describe processing and physical capacity, and the part families can be produced in dedicated manufacturing cells. Okay, we'll see cell technology later. Chaku. Remember, to remind me, chaku. Group technology benefits. Okay, this I've already mentioned. There's now improved design, reduce raw material and purchases, simplified product planning and control, improve layout. You don't have to, the same group of products can be grouped together to be produced using the same machine. Okay, so same machine producing similar products are going to be grouped together. So it's going to be improve layout and routing and machine loading, okay, as well as reducing tooling setup time. So there's a lot of benefits in terms of group technology for manufacturing, especially. So when that is basically in design, there are two main things: engineering drawing as well as bill of material. But in production, so once you design it, you need to come up with production drawing. Production means how to make it. We cannot just use the design drawing because we need to know how to assemble the parts to come up with the final product. So we call it as assembly drawing. Assembly means Nihongo wa kumitate. Kumitate ne. So assembly drawing, kumitate zu. Okay. So kumitate zu. assembly drawing, and then assembly chart, route sheet, work order, and so on. So the explanation is this. So assembly drawing is exploded view of product. So this is an assembly drawing. It will detail relative location to show how to assemble the product. For example, this is a hexagonal headboard. So if we can imagine. So final product is this will join here. Okay, this will join here. Wakarimasu ka? Mieru ka? So join here, this join here, this will join here, and it will become your final product. This is Titan for this. This is for this. This is for this. So this is assembly drawing. So you need to be able to imagine this assembly drawing, so that when the manufacturing or production try to make it, they can make it. They can assemble it. So not only this, there are many other types of drawings. It's very simple example. Assembly chart is actually identify the point of production where components flow into sub-assemblies and become the final product. So it is actually joining. For this part, will join this to become sub-assembly. SA is sub-assembly. So this sub-assembly is called left bracket assembly. Wakarimasu ka? Okay, this angle, this washer nut will become right bracket assembly. Okay. And this walnut roller washer will go into A3. And this is not only, this is only some part of it only. Okay. So this and A1 and A2 will join up with A3. So this probably will go this way. And this is Pokayoke inspection. Pokayoke wa Bakayoke. Bakayoke. Kita kotonai desho, minasan. Atau de shirabete kudasai. Bakayoke. Exercise for you. Exercise for all of you. I want you to write in one sentence what is Bakayoke. Give one example. Okay. After that, I will write to you. Part number tagging, box packing. So this one is final product. Okay, box. So this is assembly chart. Okay, assembly chart, and it can go for any products, for burgers, for everything. Okay, in production also we have route sheet. Route sheet is you list the operations and times required to produce a component. So it starts from process 1, 2, it will go until process 4. So the first process is auto insert. So this is the operation, setup time, operation time. So this is called a route sheet. Route means flow. Route, okay, flow. Route from 1, 2, 3, 4 until you complete this first component or first part, then you join up together. So there's a route for every instruction, basically. It's an instruction sheet. Okay. Same like work order. Order is instruction to produce a given quantity of a particular item following a schedule. Usually work orders go with schedule. So now it's already in production. Okay. So it's more of how to transition into production. So this is the instruction to produce, work order, quantity, start date, due date. Normally this is for batch production. Okay, batch production meaning producing in one lot size. This lot is 125, one batch. Okay. For example, when you produce shirts or even long pants or jeans. So they make a batch of, for example, 50. Okay, just 50 only sew the, with the sleeve, for example, okay, or for the collar. So they have this what they call instruction according to the given quantity, according to the given quantity. Another important document in production is what we call as engineering change notice, ECN. Some companies, they call it engineering order changes, okay, engineering order or EOs. But ECN, engineering change notice, it is a correction or modification to a product definition. So that's why it's named change notice. You give a notification that, for example, we are not going to use material A, we are going to use material B because of some technical reasons, for example, okay, because of improvement. So this is correction. You need to do continuous, not to say continuous, but necessary correction or modification. And they are going to be, they will issue new drawing. They will issue new engine drawing. They will issue new bill of material. Understand? Okay. So ECN or engineering change notice is quite common in production. Okay. And it is quite common with long product life cycles. Product which has actually been used for a long time. For example, you cannot find this particular manufacturer of a certain material. So you need to find alternative material to be used. Okay. Long product life cycles or long manufacturing lead times. COVID, disruption in supply. We cannot get this material. So we can, source similar materials and we need to issue engineering change notice. Okay, issue means you come up with a new, drawing, or rapidly changing technologies. Okay, so this is common in product, long product life cycles. Because we have a lot of changes and a lot of modification, so we need to manage this. So when you manage ECN, it is called configuration management. Okay, so the need to manage ECN has led to the development of configuration management systems. Why? If you don't keep track of the changes, then you will lose identification of the product. Okay, how do you know which material have changed, when it was changed? So you have to have a record. ISO 9000, for example, require records of changes. And also, if there are customer complaints, if there are safety concerns, accidents, if there are accidents because of changes, so you need to actually have a system for that. Okay. So it's products plan and changing components are accurately identified and controlled. So any changes, you monitor and you record that. And also because accountability for change are identified and maintained. Okay? So it is very important configuration management in ECNs. Right? Any questions so far? Okay, another aspect of documents for production is because we have so much document, too many drawings, too many what do you call changes and so on. Many companies, including Boeing, including Intel, all big companies, even Toyota, develop product life cycle management. Because you have a lot of software, a lot of CAD/CAM system, programs, okay? Everything is in different software, in different design software. So you want to integrate all these together. Not all, if not all, because some of them are very difficult to integrate. So elements of product design and manufacture are integrated together. So when they're integrated, it is called this product lifecycle management, what do you call software, okay, which will include these elements: product design, CAD/CAM, design for manufacturing and assemblability, DFMA, routing, materials, assembly, environmental issues. So we have a, a complete system to to keep history. And also when you develop new product, you don't have to come up with a new drawing. Understand? So when you come up with a new product using the same component, you carry over. So you can have it continuously. Okay, so it is called a product lifecycle management system that actually being used by many companies. Okay, I'm not sure small companies probably they don't have extensive use of product lifecycle management. Okay, and especially because we have very short life cycle of product, right? Meaning products are being designed, for example, 3 years for new car, new model. Okay, 3 years is very short time. Okay, product cycle. Okay, so if you do not have a PLM, then you need to restart again. You need to redraw. You need to find a new specification. So it is time wasting. So by having a system, so you are able to actually maintain or shorten these 3 years. Probably in the next new product, you can develop in 2 years. Okay, that's why handphone very fast development because of they have this PLM. They just carry over the parts, carry over the the things that they do not need to change. And also in production, they can start production immediately. They don't have to start from zero or from scratch. They already have the system. Okay, so that helps in terms of what we call product design, product design. And of course, I think in service as well. Okay, so now we move a little bit to service design, but before that, I want to show you okay, this is Miro. I need to share the sound. Okay. Minasan? VR technology, virtual reality technology for Mazda, everywhere today. So I don't have to go to the showroom to see the car. So imagine this is, oh, it's already finished. Okay, it's probably, oh, they have developed this. Imagine when during design, this is already completed design. During the design stage, you put the concept and you try to visualize and see for yourself. Right? So that's why today, because of these technologies, you can actually develop products faster, and you can actually imagine how the customers would experience when they actually use the vehicle. Not only that, we can actually also you can also actually determine customers' perceptions, feelings during the design. Okay, right. So that's how companies are actually trying to reduce the time. There is no VR technology when I started 20 years ago in Mizushima, 1985. No VR. So what do we do? What do you have to do? Imagine and make the model. Make the actual model and feel for yourself. But today, because of this technology, you can actually you can feel and see by yourself. Okay, you can Google by yourself and and see the different the amount of advancement that is actually VR. Okay, sorry. Okay, I don't want to spend too much time. You can actually check out for yourself. There are a lot of video clips that's available for you to right. The next thing that related to design, because you don't only design products, you can also design service. Service must be designed. But of course, this is not a service design class. This is just operation management. So in service design, service typically include direct interaction with customer, because the difficulty with service is, for example, now I'm trying to teach you something. Okay, I'm trying to provide education service to you, teaching you. There is interaction, there is a direct interaction. But because of the barrier between you and me today, there is a barrier. The barrier is the ocean between Malaysia and Japan. There is a barrier, barrier, because physical distance. I cannot feel how you respond to my teaching, because this is different. I can only see your face. I cannot see your hand movement, your gestures. So effective, not effective. Or you understand, or I explain clearly. Also, because the direct interaction is not happening actually. Okay, because we are not physically together. I always believe that teaching must be together. I don't believe this new kind of teaching, because I know some of you may be doing something else at the same time, and trying to just listen, and maybe if you understand, then you listen. If you're interested, you will listen. If you're not interested, you won't listen. Tabun ne? Wakaru ka? Minasan. Wakaru, yes. So that in service design, okay, I introduced this simple concept of process chain network. Process chain network. So in a process chain network, you will analyze, the analysis focus on the ways in which processes can be designed to optimize interaction, okay, between the firm and their customers. Okay, it's like this, an example of PCN network, process chain network analysis. So this is the supplier's domain process, and on the other side is the customer process. Okay, there is a customer process and supplier process, right? So either you go from the supplier independent processing, or you go to the customer independent processing, and these are the so-called surrogate interaction. When you have the supplier making for you, then this is the restaurants making themselves, and they offer you to the customer. So the direct interaction occur here. Okay, so there is one is totally by the suppliers, Secondly, there is an interaction with consumers, right? If you buy a sandwich from 7-Eleven, okay, so you're only getting this service, right? So it's actually getting from the supplier. But if you go to Subway, you're getting it from here, right? Because the customer asks for the different ingredients. They assemble, of course, this is at your home, this is at home, but in Subway, this is partly consumer interaction is they become the surrogate interaction. Surrogate means, okay, we'll see the next slide. Okay, direct interaction region include process steps that involve interaction between participants, you and me today. Surrogate means the region in which the process steps that one participant is acting on another participant resources. That means they are partly involved. Okay, they are partly involved. Okay. And independent processing is in which each has their own maximum control. Okay, so in this case, actually, this is the sandwich is made by the person himself at home, actually. Assemble sandwich at home. Okay, of course, Subway is here, Subway is here, and 7-Eleven is here. Right, so we need to actually see the kind of interaction that is actually going to happen between the customers, and also how you design it. Do you want it to be totally with the customers, or you just want your product to be, mass produced? This is mass production. This is mass production. Okay, this is mass production. Make many and sell it. But here, of course, this is customized. This is customized individual. But Subway, when you say Subway, is mass customization. Mass customization. So there is different. How do you like your Subway sandwich? With this kind of bread, Italian bread, with only onions, with only so it is mass customization. So for mass customization, so you need to design your service that will actually satisfy customers fully. Okay, so that is the PCN analysis. All three regions will have similar operating issues in terms of quality, in terms of meeting the time to process it. Okay. So the service operations exist only within the area of direct and surrogate interaction. And this analysis will provide insights to help us position and design processes. So where are you going to position your product? Okay, at the mass production or mass customization, okay, so that the customer is involved in designing means determining his own sandwich. Okay, can you change your design in McDonald's? You go to McDonald's, you order. What can you order sandwich in McDonald's? Yuma, can you? Where is it? Where is McDonald's?
I guess direct interaction.
Direct interaction.
Because
yes. Which side? The left side or the right side? There is from the left side, from the supplier process domain, or from the customer process domain?
Suppliers process domain.
From suppliers?
Suppliers.
Supplier process domain?
No.
Okay. Yusuke, you think about it. Okay, Yuma, you think about it. Yusuke, McDonald's. Who can answer this?
McDonald.
McDonald's. Dochi. Kochikaraka. Kochika. Kochika. Kochi. Okay, I just say answer which one. This part or this part? Direct interaction A or direct interaction B? Who says it is actually direct interaction A?
I think A. Yeah.
Okay. Who else? Who? Which one? A or B? McDonald's. Oh, is it A or B? Whoever wants to answer, just switch on your mic and just say, you know, A, B, up to you. Yuli? Don't worry. You give the wrong answer also. I cannot touch you also. I cannot, you know. Yu Hong.
I think it's A.
Okay. Wang?
I think it's A.
Yuli?
A.
So most of you believe it is A. Yes, you are right, because it's actually coming from the supplier process domain. You cannot change the McDonald's cheeseburger, you know, ingredient. It is it's the same thing that you will get. Okay, it is not like Subway. Subway, you can actually, the customer is involved in the end product because it's according to his choice. Okay, so that is so that's why you need fast service in McDonald's. Okay, so how do we improve service efficiency? Adding service efficiency, meaning that how do we improve productivity? Because service productivity is low. Notorious means very, very low because of customer involvement in the design or delivery or both. And as more customer interaction involved, then you will complicate the product design. You will complicate the end product actually, because the customer demands many kind of different individual tastes. Okay. For example, if you go to hair salon, okay, ladies, you know, you go to haircut. So someone, you know, I want to cut this way. I want to have shampoo. I want to, you know, dye. So it will complicate the product design at the end of the day. Okay. Or, you know, what else? All services are notoriously very, very low. Okay. So how do we actually improve service efficiency? So especially today, that you can actually improve, you know, a lot of you can improve efficiency by limiting the options. That is why when you go to specialized services, okay, specialized services, I don't know, like healthcare or dentistry or, you know, they will have limited options. You only have this, you know, this available services for the customers. Okay, that will actually improve efficiency for the organization. They do it with purpose. You know, with purpose. They say, oh, we don't have this because they don't want to be involved in the, you know, the difficulties in trying to meet customers' expectations. Okay, or delay customization. Delay customization means some processes of the what do you call service, you put it at the end later on. Okay, so delay customization. I don't like the example given in the book, but I'm just mentioning it. Okay, delay customization means hair salon. Although shampoo and conditioning are done in a standard way with lower cost labor, the color and styling, customizing are done last. That means that's what we call a delay customization. That means the coloring and the what they call styling is done last. They don't do earlier. There's delay customization. Only some customers want that, so it is going to be put at delay. And also restaurants, okay, they have delayed customization or modularization. You modularize the services that you are going to offer, okay. No, some what you call services, you cannot come when you want. They have booking system. Okay, that is also adding efficiency. Booking system, right? So that is also being done. But today there's a lot of automation being done in service. I mentioned about Uniqlo automated checkout counter, right? So you can see that. Or even you go to supermarket today in Malaysia, there are Tesco which actually have automated, checkout. So those are things which are automated. Have you heard of RPA? Robotic RPA. Okay, I cannot write this. Robotic process automation. But before that, let me just finish this moment of truth, which is actually the critical moment between customer and the service provider. That is the moment of truth, whether the customer is satisfied or not. Okay, so there are instances of moment of truth between the customer and what they call the service providers or the company. Can you hear? Can you see this?
This demo shows how an RPA tool works. RPA can be applied for the automation of transactional rules-based tasks where structured data and clear predefined rules and parameters are used. The solutions are easily and quickly designed, tested and implemented. They are designed to require relatively low investment or expenditure. This demo shows how a process such as the creation of invoices is executed by an RPA tool. You will see how routine activities can be easily performed by the RPA tool based on predefined rules. The RPA tool used in this demo is Blue Prism. The key steps for the creation of invoices are as follows. In this process, the invoice request is received and opened, relevant data is entered into SAP, and the invoice document is created. At the beginning of the process, the software robot opens the correct environment in SAP and logs in. An invoice request is received by the software robot via email. The robot opens the email and the attached Excel template and scans this thoroughly. Different checks are performed by the robot to determine whether the data from the Excel template is of a certain quality. The software robot runs the transaction code for the creation of invoices in SAP. Subsequently, the invoice data from the Excel template is copied and pasted into the relevant fields in SAP. The robot recognizes if essential information is missing in the invoice request. If this is the case, The robot sends an email to the invoice requester with a request to adjust the specific invoice data. When all the data is entered in SAP, the robot creates the invoice by running the correct transactions. The invoice is then correctly saved for sending. At the end of the process, the robot sends an email to the requester with confirmation that the invoice has been created and moves the invoice request to the relevant subfolder in Outlook. Additionally, all the used applications are correctly closed. You just saw an example of how robotics can be deployed for a finance process. Next to the finance processes, there are many other opportunities for RPA that exist across other functions within the organization. Examples of these include customer care, business operations, IT, and HR. So, are you on the road to robotic automation? Success here isn't about if, but when. Now is the time to get started.
Okay, so first time having seen RPA, robotic process automation. You've seen before, Mino, Shota-san. Okay, then I can give you assignment. How to give me one example of RPA, how to use RPA in university, in Graduate School of Business Administration, Meiji University. Find one process, tell me how to apply RPA into the into the process. Okay, you need a process, service process, right? So there's a lot of ways to improve service processes today. Okay, I'm not asking you to do the programming. I'm just asking you to just think it just now. I think we were talking about adding service efficiency. Okay, and we can use automation, robotic process automation today to actually. Can you see the slide? Can. So there's many ways of adding efficient service efficiency today. Automation will reduce cost, but not physical automation that we see. Automation like robot, physical robot, but now processes which are using softwares. Okay. In service, because the process is very, high level of customer interaction. So we need a different kind of documentation. But the most common one is job instructions. Okay, job instructions, or especially things that you must do. Okay, scripts and storyboards. Scripts and storyboards are very common. Okay, cannot write it anymore because of internet probably. Okay, scripts and storyboards are other techniques. Scripts means have you ever called an operator when you have problem with a certain product? You call operator to ask for help. They have actually scripts and storyboards. This question, this is the standard answer. This question, this is standard answer. Okay, so they don't run away from the storyboards. Okay, so that's how they actually standardize services. Call centers for banks, for purchases of electrical goods, computers, and so on. Okay, so those kind of documents are used for services. Yeah? So, for example, a bank. This is an example of drive up teller service guidelines. Okay, drive up means you drive to the teller. So this is the guideline given to the what they call teller service, the teller herself or himself. Be especially discreet when talking with the customers. Okay, so this is provide written instructions mark lines to be completed or attach a note with instructions. Always say please and thank you when speaking to the microphone. Establish. So these are the kind of instructions or guidelines or job instruction basically that is given. Okay. One of the tool that we can use in making decisions about product design is called decision tree. Okay, I'm not going to go to this method or this technique detail. I'm just going to briefly explain to you so that you know it is there. Okay, it's called a decision tree because it looks like a tree basically. Okay, application of design trees to product design. It is useful when there are a series of decisions and outcomes that you have. Okay, and you lead to other decisions. So that's why it's called a tree. So the procedure is to include all possible alternatives and nature, including doing nothing. Doing nothing is also a decision. Okay, do A, do B, do nothing. Do nothing is also a decision. Okay, and you have to enter payoff. Payoff means how much you're going to actually expect in return, a payoff, okay, or gain. And you determine the expected value for each branch and prune the tree to find the alternative to the best expected value. Prune means you cut off the tree. So for example, you have this decision of purchasing cat. Okay, you want to either when you want to develop the new product, you want to purchase a computer-aided system, which is CAD, or you want to hire and train engineers, which can do the design for you also, or do nothing. Okay, there are three alternatives to embark on the so-called certain product design. Okay, you purchase CAD system, hire engineers, or do nothing. If, for example, okay, there is two scenarios: high sales, low sales. Okay, high sales, low sales. So for purchasing CAD, you predict there is a 40% chance of having a high scales and 60% chance of having a low scales. Same as this. No, the product is going to have this certain percentage of probability of having high sales and low scales with the new product. Okay, and okay, let's see here. Now, so by having a high sales, these are all the data. Okay, all the let me just go to. Right. So this is saying that the cost of the CAD system is 500,000. Okay, the CAD cost is 500,000. You can look at example 3 actually. And hiring or training to engineers is only 375,000. However, manufacturing costs should drop from $50 when manufacturing without CAD to $40 each when manufacturing with CAD. And they are going to produce 25,000. Okay, that's why the coming of the revenue is coming from 25,000 processors selling for 100,000. So 25,000 processors multiplied by 100, you will get a revenue of 2.5 million. Okay, this is 2.5 million is coming from 225,000 times 100. This is the manufacturing cost. This is the cost of having this CAD system. So the net revenue is 100,000. So the expected monetary value, EMV. Okay, EMV is expected monetary value when you purchase a CAD system is 0.4 of 1 million plus 0.6 of loss. Okay, minus 20,000. So the expected value is 388,000 if you buy CAD, if you invest in automation, basically. Basically, if you in fact invest in automation, the expected monetary value or the payoff is 388,000. You have another alternative, which is actually okay. Let's do for the rest. If you hire and train engineers, so the revenue is still the same, and the manufacturing cost is going to be higher because you do not have the automated system. So it's $50 times 35,000, which is 1.25 million, minus the hiring and training costs. So you're for high sales, if there is high sales, if there is a low sales, so you expect this amount of revenue. Okay, so this the expected monetary value EMV is 0.4 times 807,000 plus 0.6 times 25,000. So you will get 365,000. Okay, so 365,000. Of course, if you do nothing, is you get nothing, zero. Okay, you do nothing, but it's still what they call, you're not invest. Do nothing mean you don't have a new product. Basically, new product development, zero. Okay, no new product. So in this case, it is cheaper to hire and train engineers. It's cheaper to actually hire and train engineers rather than purchasing a CAD system. So this is what is called as a decision tree analysis. Decision tree because it looks like tree. So you prune out the oh, sorry, the best is actually purchase CAD. I'm sorry, because it is the highest payoff. Sorry, 388,000 is the highest payoff. This is low payoff. There's no payoff. So you prune this. Prune means you cut off this, cut off this, and cut off this. So the answer should be purchase CAD system. Okay, purchase CAD system because it's going to give you the highest return. Not the 365 is obviously lesser than 388,000. Okay, sorry about that confusion. Okay, the answer is purchase CAD, not hire and train engineers. Okay. Any question? Any question about this? No, I'm not going to give you an exercise about this. You can, if you're interested, you can go at the end of the chapter and do it by yourself. Okay. Okay. So the final thing is to move from design to production. So you need to transition. Okay, you have to have transition to production. So you must know when to move to production. In car industry, automotive industry, car production design stage will take, like, for example, 2 years, 3 years. They have pre-production. We call it pre-production. P1, P2, P3. Now, but now probably there's lesser pre-production or trial production. Trial. Okay, trial production. So that is the transition. That means before you actually transfer the design, because you need to prove the design, then only can mass produce it. So product development can be viewed as evolutionary and never complete. So after new product, you need to produce, mass produce, and then new product. So product must move from design to production in a timely manner. Timely manner means the production is already ready. So the readiness of production, it's concurrent actually. Product development is actually from the design, and it is actually, it goes through pre-production, mass production. It's a complete product development. It's not, there's no cut off. Okay, this is complete design. Then you pass over. There is no such thing as pass over. There is a continuous process of transferring and transition, and that's why the word transition to production. And most products have trial production period to ensure producibility or manufacturability, because you develop the tooling, you develop the equipment, new process, new quality control system, not new quality control system, but new specifications. There are some new products, new parts, new materials, new technology to inspect or to confirm quality. And of course, you need training, new technologies, new things. You need to actually, there will be a learning curve, learning time for you to understand how to actually make the product. Okay, and also to ensure successful production. Then another 3 years, the cycle repeats. The cycle repeats for new products and new service to be introduced. Okay. Right. I want to talk a little bit about this. Is at the end of this chapter. There is a supplement to this chapter actually. Okay. Before that, responsibility must also transition as product moves through the cycle. That means the production will take over from design. And different approaches are being used by companies to actually do the transition. But again, I said that it's a product development team. Okay, so it will actually transition into mass production. So just a little bit about sustainability in the supply chain, because we are talking about operations management in the supply chain, meaning the product is along the different suppliers and consumers, okay. I'm not going to go detail. I'm just going to give you a very brief about sustainability in supply chain. All of us have heard of corporate social responsibility. You know what corporate social responsibility is? That means how the company that is actually producing products and services must be responsible that they do not damage the environment. They actually give back to society. And, they have, stakeholders, that means including consumers, have very strong opinions about environment. They demand that producers and also companies do not produce products that damage the environment, pollution, okay, and using materials which are destroying the forest, for example. In Malaysia, there's a lot of forest. So Western countries don't like Malaysia because they say we destroy the forest. But they already destroyed the forest. Okay, the forest is no more, but we have the forest. You understand? So doing what's right can be beneficial to all stakeholders. That means we have to think about the society, we have to think about the next generation. The next generation, our children, our grandchildren, okay? So we have to be responsible to society. So what does it mean by sustainability? A lot of things have been said about sustainability, and it's going to be repeat again, which is actually meet the needs of the present without compromising the ability of future generation to meet their needs. Okay. And it's more than going green. It's not only green, it's actually trying to preserve the wealth of the world. Okay, it's everybody's responsibility. Use less plastic. But not only use less plastic, don't throw the plastic, more important. Don't throw the plastic. In Malaysia, we say don't use plastic. No, use the plastic, but throw properly. No mask. Everybody use mask today. Everybody throwing masks everywhere. It is not responsible. Throw the mask properly. So everybody is responsible for making sure that we preserve the resources. So you must look at the product life from design to disposal. That means today you design product, you must design product that is friendly to the environment, that can be reused. Okay, so we call it circular economy. I've mentioned to you already before, circular economy, circle, the economy, will turn back. Then it will actually be reused back. So the product or service itself is a small part of the much larger social, economic, and environmental system that exists in the society, right? Politician only talks about sustainability, but when they make policy and rule, it destroys the environment. So we need to, appoint politicians who are going to, be helping helping this. Right. So we must understanding system that allow more informed judgment regarding sustainability. So every one of us is responsible to understand the system for that. Right, common thing. Let me just. So many inputs that actually used by inputs to operation are held by the public. Okay, many inputs have market prices, but others do not. Those that do not, that are held by the public or in common. Okay, those are in common. Common resources are often misallocated. Common resources, that means things which are in public are not being properly managed. So we want to, manage these common resources. So what are the possible things that we can do? Okay, we can move some of the common to private property. We can allocate the rights of who manage these common resources. Rivers, all these jungles, okay? And we must have regulation how to actually protect the common resources. Oceans, who owns the oceans? Who owns the ocean? It's, people just dump into the ocean, okay? Okay, I will send this this file, okay? And this. Okay, this common thing in environment. Every one of you know already. Triple bottom line. Do you know triple bottom line? People, planet, profit. Everybody must know this. When you talk about sustainability, we have to think about how it will actually. You want to maximize the triple bottom line. Triple bottom line means how it affect the planet, how it affect the people, how it affect profit. Companies must make profit. We are not against companies making profit. No, we are not. But when they make profit, make sure that they do not damage people, they do not damage the planet. So this is, we need to minimize raw material, energy, water, waste. That's why Toyota production system mudah, mudah, very, very useful and very important. I think Japanese people understand, many, not to say all, okay? Many people understand mottainai. But in Malaysia, mottainai wakaranai. Mottainai wakaranai. Maybe tabun wakarimasu ne. Demo shimasen ne. Dame ne. So triple bottom line, consider the system necessary to support the 3 Ps. So the decisions about affecting people must be considered, and globalization and outsourcing will complicate the task because global companies sometimes they are responsible for damaging the environment. Okay, so it's a very complicated and delicate issue, very difficult. Okay, very difficult. But big corporations sometimes double standard. Big corporations, double standards. In some countries, they practice. In some other countries, they don't practice. So that's reality, okay? Even I think Japanese companies, in Malaysia, they may be not doing like in Japan. Businessmen, onaji the shop. So they come to Malaysia, beside my house, there is a big factory, Japanese factory. Sometimes I see, at night they produce gas and release to the sky, to the environment. So Japanese company. So I think in Japan they follow the rule, but in Malaysia they say it's okay, no need to follow because Malaysia not very stringent, not very strict. Right. So 12:30. So a lot of things. This is an example of Walmart objectives of trying to be sustainable, responsible corporate entity, prevent exposure to substances that are considered harmful or toxic, promote health and wellness. But it must translate into actions. It's not only just on paper. On paper is very nice, but it must be seen, seen to be working. So the planet's environment, trying to conserve scarce resources. Energy today is energy, electricity, energy. Fossil fuel, solar energy. Trying to come up with sustainable energy sources, wind energy, or even water. Okay, and this concept of footprint, trying to reduce the carbon footprint for a product or even for human being. Okay, and social environmental sustainability don't exist without economic sustainability. So you need to also sustain the business. It's wrong to say that you cannot make money, but the amount of money that you make must be reasonable. Okay, there's a whole concept of design and production for sustainability: reduce, reuse, recycle. So this, or even in manufacturing, we call it design for manufacturing. In UK, there is a law that end of life. Okay, end of life. This one, end of life. EOL. Computer end of life. Manufacturer has to buy back. Car end of life. For example, end of life is 20 years. End of life, manufacturer has to buy back or dispose. Responsibility of manufacturer to dispose because they make it. Okay, so that is the concept of end of life and also design and production sustainability. Right, there's a lot of things that can be done to actually measure. There's a lot of even measure. Okay, there are end of life phases, automotive and incorporate disassembly, recycling. There are regulations and industry standards, product design in terms of sustainability, and so on. Okay, there's a lot of regulations today that is in advanced countries, but in developing countries, it is very, very, very slow, including Malaysia. Okay, sustainability issue is probably less important than political issue. And also and COVID issue. So COVID is more important than sustainability today in some countries. Okay. Right. I think I will share this slide with all of you. I will send to all of you. There is a standard. Okay, ISO 14000. You can Google and see what is ISO 14000 for environmental management standards. Okay. Okay, so more jika ni narimasu. Okay. Any questions? Nanka semua enggak arimasu. Nai? Minna wakarimasu? Zenbu wakarimasu? Yuhong, zenbu wakarimasu?
大体わかります。
ほとんどわかりました。はい。いいですね。OK。